Hello, everyone. Welcome again to the Dr. Jeff Show podcast. As you know, you can get this podcast on Apple, Google, Spotify, Edify, Liftable. I'm getting used to saying all 5 of those. And if you can also see it on YouTube, so send that to your friends as well. And if you get a chance, go to your favorite podcast site and review the show, because that helps bring it to the attention of other people. That's important because this is the show where I interview major thought leaders from various fields of influence to show how worldview changes everything. Have you ever been in a class or in a conversation and somebody says, "I cannot believe that you would question evolution because that is what all scientists believe and you must be some kind of a nut." Our guest today focuses on intelligent design. His name is Casey Luskin. He's an attorney who also is a professor, a PhD in biology from the University of Johannesburg. Casey's spoken to Summit Ministry students many times in the past, and he helps students understand intelligent design and irreducible complexity. If you're a science geek, you're really going to get into this. If you've always sort of wondered about science, but maybe been a little bit nervous about it, this show is for you because Casey breaks it down into straightforward details to show how there has got to be an intelligent mind behind the universe. Welcome to the show. Dr. Casey Luskin, welcome to the Dr. Jeff Show podcast.
It's great to be on with you.
I'm really looking forward to our conversation. And I know I always say that at the beginning of each show, but I love learning. And I love learning from the organization that you are a part of, the Discovery Institute, focusing on intelligent design and on economics. You're the associate director of the Center for Science and Culture at the Discovery Institute with a doctorate in geology.
That's right. That's correct.
Casey, I really want to talk about intelligent design. I want to talk about it all the time. You know, I get Steve Meyer's books and I give them to my kids and we talk about it because I have a couple of kids who are STEM oriented. But I'd love for you to just sort of give us the lay of the land. What is intelligent design? Why is this an important conversation for the time in which we live?
Sure. So intelligent design is a scientific theory. And by the way, I understand why all you want to do is talk about intelligent design. That's how I've been for most of my life. But then when you actually get a job in the area, it's like, well, maybe I want to talk about other things sometimes too, because it's like you can't just talk about intelligent design. But I do enjoy talking about intelligent design, and I understand other people need to get their fix, so I'm happy to help with that. So what is intelligent design? Intelligent design is a scientific theory which says that many aspects of life and the universe are best explained by an intelligent cause rather than an undirected cause, such as natural selection. So what does that mean practically? Well, there are many things we see in nature that appear to have been the result of an intelligent mind, of an intelligent agent. They didn't come about simply by random, unguided, chance-based processes. And so intelligent design is looking at nature and asking, can we identify when there are features that are the result of an intelligent cause? So what are some examples of this? Well, let's go, there are many examples of this that we could talk about, but let's go back to the very basics of life, okay? Everybody in their high school biology class, and I assume that most of our listeners and viewers have taken high school biology, you learn about DNA, right? DNA is sort of the foundation for living organisms. It is a molecule or molecules found in every single living cell. Well, not every single, but almost every single living cell. Every living organism has DNA, and it has these nucleotide bases. They're coded for with the letters A, C, T, and G. It stands for adenine, cytosine, thymine, and guanine. And those nucleotide bases are strung along the backbone of the DNA molecule, almost like rungs in a ladder, or you might say stairs in a spiral staircase is probably the best analogy. It's a beautiful molecule. And the ordering of these nucleotide bases is what determines the order of the amino acids in your proteins. Okay, and what are proteins? Well, proteins are very important molecules that are sort of like the workhorse molecules of the cell. Okay, they perform all kinds of cellular functions, enzymes. They can form structural components. They're structural proteins. They can carry molecules from one part of the cell to the other. They build molecular machines which perform many of the cellular activities and work going on in the cells. And experiments have shown that in many cases, the sequence of the amino acids in a protein is vital to a protein being able to perform its function. Okay? And so what you have in living organisms is literally a language-based code that is composed of these 4 nucleotide bases. And the ordering of those nucleotide bases in this language-based code determines the shape and structure of those proteins in your body. And if the ordering of those nucleotide bases is just slightly incorrect, then in many cases, a protein will not work properly. So the question then becomes, what orders the nucleotide bases in your DNA in the right order? To put the question in a much more sort of just very base level, what generates the information in our DNA? Because it really is information. There is no physical or chemical law that dictates the order of the nucleotide bases in the DNA. So we have to count for the order in which, how do they get in the right order to produce all of the proteins and molecular machines and other body structures in living organisms. It is a language-based code in your cells that specifies all the proteins and the various structures needed for living organisms. And so what we see at the heart of life is a language-based code. But where in our experience do things like language-based codes come from? Well, in all of our experience, they have only one known cause. You can answer that question, Dr. Jeff. What is the one known cause in your experience of a language-based code?
If I'm hearing language, I know that I'm speaking with someone who is a mind, not just matter.
That's right. It comes from a mind. You do not get language from undirected natural processes. You need a mind to create the information that is making that language meaningful and intelligible. And that's what we have in our cells. Every single living organism has in their cells DNA with a language-based code. So I would say at the heart of life is something that is one of the most powerful lines of evidence, most consistent with everything we know about what intelligent agents generate, which is language-based codes, language information, is what we find at the heart of life. So there's a very compelling argument for intelligent design in living organisms. And of course, this is just the very beginning. There is so much more evidence for intelligent design in nature. We can talk about that if you want, but this sort of just sketches out what intelligent design is and why it's such a compelling explanation for what we see.
Yeah, Casey, I do want to get into several different lines of evidence because I know you focus on a lot of different things at Discovery Institute. And I don't want people to miss that word that you used, information, how central that is. Because information theory is at the heart of everything that makes modern life run. We think about information in economics. We think about information in computer science. Then we also think about information in living organisms and other sciences that are so critical. So here's the thing I always think about when I think about DNA. I remember Richard Dawkins' first famous book, anyway, called The Blind Watchmaker. And the statement that grabbed my attention the most that I share with our students here because it seems so dour and anti-life, he says, DNA neither knows nor cares. DNA just is, and we dance to its music. If somebody were to say that to you on a bus and you got a couple of minutes with them, where do you start with that kind of a conversation?
Yeah, so this is a classic Dawkins kind of idea. The idea that at base, we are just basically sort of compartments for our selfish genes. And we're just being driven by the DNA that has programmed our bodies and our minds. And of course, evolution, according to Dawkins, has programmed the DNA. So we are nothing more than vessels that help our selfish genes to replicate and make more copies of themselves. And we dance to its music. That's a great quote that you dug out from Dawkins there, Dr. Jeff, and I certainly very representative of his viewpoint. So is that all we are? Are we nothing more than essentially vessels for our selfish genes? And is life no more meaningful than that? Well, I would say the answer to that is no. I think that there's a lot more to life than merely being the vessels for our selfish genes. Let me give you another quote. In fact, I want to give you a little story from when I lived in South Africa here. I would often go to a museum in South Africa near Johannesburg where I lived called the Maripang Hominid Museum. And in this museum, there was a quote from Richard Dawkins that spanned from ceiling to floor, actually in two places in this museum. And every single school child in Johannesburg would go to this museum, and they would be taught about the sort of the evolutionary origins. But they wanted people not just to think that we evolved from ape-like ancestors or common ancestors with living apes. They didn't just want people to think that. They want them to get the full materialistic message. And this is what this quote said. It says, "We are survival machines, robot vehicles blindly programmed to preserve the selfish molecules known as genes." Now, that's sort of
a religious statement. So that was in a public museum.
In a very public museum, probably arguably the top hominid studies museum in the world. Okay, the Meripim Museum. It's a wonderful museum. I mean, it's as world class as you'll get as far as science museums go. If you ever go to Johannesburg, I highly recommend visiting, and I'll give you my visitor's guide that I wrote up for it. But this museum is trying to promote not just the evolutionary account of human origins, but the implications, the philosophical implications of that account, that all life is about is basically preserving our selfish genes. And that is a quote from Richard Dawkins. So this really is sort of, I would say, we can talk about evolution as a science, but it certainly has broader philosophical implications for life. And I don't think anybody who is coming from sort of a Judeo-Christian worldview, who believes that there is a creator who designed life for a purpose, that life has meaning and value, and I'm talking about ultimate meaning and value that goes beyond just, survival and reproduction. If you believe that life is more than just survival and reproduction, then you cannot accept this sort of evolutionary interpretation of what life is all about, that we are survival machines, robot vehicles blindly programmed to preserve the selfish molecules known as genes. So the good news is that I think that statement from Dawkins, and the one that you read as well, is contradicted by the scientific evidence. Let's talk about not just the complexity of life, but human behavior. Okay, so is human behavior just geared towards nothing more than survival and reproduction? Well, according to the modern field of evolutionary psychology, the answer is yes. Not just your bodies, but also your brains. Everything you do from the time you get up in the morning to the time you go to bed, every day of your life, you're doing it because you were programmed to do that by your genes, which have programmed your mind to behave in certain ways, which foster your survival and your reproduction. That is evolutionary psychology. We're not just talking about, basic things like you have to eat and drink and poop every day, but everything from like, what breakfast cereal do you like? Or why are you attracted to your boyfriend or your girlfriend? Or why did you marry your spouse? Or why do you like to sing? Why do you like to dance? Everything you do is just, you're programmed by your genes. Okay, so it's sort of the denial of free will, and it's the denial that you're a real person, that you're something that exists in sort of an existential, real sense. You're not just sort of this consciousness produced by this meat computer between your ears, And so the good news, though, is that this view of human life is totally contradicted by what we see. And there are many human behaviors which are really, really difficult to explain under evolutionary psychology, under the idea that all we do is simply for survival and reproduction. So, for example, why do human beings build cathedrals? Why do we produce art? Why do we produce music? Why do we compose symphonies? Why do we write poetry? Why do we write holy books and worship divine beings or worship God? Why do we do science? Why did Einstein spend years of his life trying to understand the deep secrets of the universe so he could uncover the theory of relativity? Why do we do all these things which are considered to be sort of higher human activities? Art, music, science, literature, love, all these activities. There is no reason for those things to exist in a purely Darwinian world. If our brains were basically programmed to survive and reproduce on the African savanna about 1 million years ago, that's when they think our modern day brains were shaped. If that is the environment which produced the human mind, there is no reason whatsoever why we should be able to do all these higher human activities, like these things we're talking about: art, music, language, literature, religion, science, technology. These things far outstrip the basic needs of human survival and reproduction on the African savanna 1 million years ago. And it really seems like human life is about something much greater than mere survival and reproduction. Can I continue on this riff for just a second?
Yeah, this is so good. I'm even just thinking about the fact that we're having the conversation, that we're using language, and that all of us who are watching or listening right now are grasping aspects of what you're saying because we have a shared language, which is something that we as human beings do that other animals don't have. We use phonated speech and articulate things that we can both understand. I mean, even that's something that basic. If someone says there's no meaning in the world, they've disproven it just by saying it.
Yeah, absolutely. I mean, there's meaning everywhere. Meaning comes from our mind, and there's meaning that we see, obviously, that humans are producing, but there's also meaning at the very basis of life. I mean, everything that's going on in your cell every second of the day is you have information in your DNA that is being transcribed and then translated by molecular machines. Sorry, we're kind of switching topics here from evolutionary psychology to genetics and biochemistry, but what's going on in your cells is you have this language which is being translated by a molecular machine in your cells called the ribosome. And that's able to read the information that's coming to it from the DNA through an intermediate molecule called mRNA. And this molecular machine acts much like a computer, which is reading sort of the hard drive, the information on the hard drive, and then processing it and converting it into some kind of useful output. So people have actually compared the information in biology to something like computer information processing, where we're reading commands and codes in our DNA, we're processing that information, and then we're generating some kind of a useful output. And of course, what is the output that cells are producing? Well, they're producing machines. These are molecular machines. They're basically conglomerates of enzymes and proteins stuck together to perform work in your cells, to perform some kind of an important function. Some of those might be producing energy. Some of them might be related to transportation. Some of them might be related to just directing other components of the cells where they're supposed to go. Or some of them might be involved in regulatory circuits, which are telling your cells, okay, time to do this, time to do that. But your cells are full of these molecular machines. By the way, as a little interlude, if any of your viewers are interested, Discovery Institute has a fantastic YouTube channel. It's it's Discovery Science News. And we have a series of molecular machine animations that you can watch that give an idea of exactly what these molecular machines are doing and how they operate. And they're very high-level animations. In fact, we have hundreds of thousands of hits on these because I think a lot of students, college students, watch these videos when they're trying to understand these molecular machines for their biochemistry courses. We get feedback like that sometimes. So anyway, you can understand what these molecular machines are doing. Let me give an example. One molecular machine is called kinesin. And what it does is it is involved in intracellular transport, basically transporting cellular packages from one end of the cell to the other. And there are these long, it's almost like a railroad track, these long molecules inside of cells called microtubules. And these kinesin molecules literally have legs with feet. And they walk along these microtubules that take this little cargo vesicle that they're carrying from one end of the cell to the other. And it's little programmed robots that are walking around inside your cells, carrying cargo from one end to the other. And this is just one of numerous examples of molecular machines. So again, so what do we got in cells? Again, we got this language-based code. We've got computer-like information processing. And then the output of this process is machines and machine-like structures. But where do any of those kinds of things come from in all of our experience? Whether we're talking about language-based code, computer-like information processing, or machines, they always come from an intelligent agent. So that's sort of a positive argument for design.
Wow. I love it. I would like to sit next to you on a bus and continue to ask questions. Casey, as you share this with someone, say somebody who's gone through biochemistry, they survived their college course in biochemistry, so they feel like they know a lot. And they say to you, well, why couldn't evolution, given enough time, produce this kind of thing? What do you say?
Sure. So first off, by the way, if you were sitting next to me on a bus or an airplane, I'd probably be one of the most boring people you could sit next to, because when I'm on buses or planes, I'm usually doing one of two things. I'm either sleeping or I'm reading. And so I'm like, I'll literally pull like a beanie over my eyes, just block out the world and sleep. Anyway, but I'm happy to talk to you, Jeff. But yeah, what about the objection? What if we had just sort of endless amounts of time in order to produce these features? Can't random mutation and natural selection do this? Well, first off, we actually don't have endless amounts of time, okay? According to the mainstream view, which I personally do accept, the Earth is about 4.5 billion years old. That puts a limit on the amount of time for which these things can evolve. And although that sounds like a lot of time, when you start to actually run the numbers, you do the math on just how complex a feature could arise in the history of the Earth, it actually starts to be a lot less complex than you would expect very quickly. And I'll give you an example. One of the things that we at Discovery Institute do where I work is we fund quite a bit of scientific research. ID critics like to say that there is no such thing as scientific research, that there are no peer-reviewed scientific papers or peer-reviewed ID research projects. I can tell you that's absolutely false, because what am I doing in my job? I mean, actually, a big part of my job is I manage our research program. I'm on the phone or emailing with scientists whose research we fund on a daily basis, managing these ID research projects. But one of the projects that we funded and that we helped to foster, this was maybe about 12 years ago, was a research project done by biologist Ann Gager and protein scientist Douglas Axe. And what they did is they took two very closely related enzymes, okay? And they said, what would it take to convert the function of one enzyme to another? When I say closely related, what I mean is they're very similar in terms of their structure and even their basic shape and their sequence. They're very, very similar enzymes. According to Darwinian evolution, this is the sort of evolutionary conversion which should be very easy for evolution to accomplish. Okay, they're very similar enzymes. They do different functions, but they're not that different. And so they started to do mutations on these enzymes to try to convert one enzyme to do the function of the other. And they tested a whole family of enzymes, okay? And what they found is that to do this very, very modest evolutionary conversion would require at least 7 mutations before you would get the new function, okay? Now, why is that an interesting number? Well, Doug Axe had done what's called a population genetics study. Population genetics is basically taking the dynamics of how random mutation and natural selection operates in a population and asking, how long will it take for a given trait to arise, or how will a trait spread within a population once it arises if it has a given sort of selective advantage. And what he found is that if you take bacteria, which is essentially one of the best opportunities for Darwinian evolution to work, where you have very, very large population sizes, very, very short generation times, very, very high mutation rates. Things should be able to evolve very, very quickly within bacteria, okay? So if you take bacteria and you take a feature which, say, requires 7 or more mutations to arise before you get any evolutionary advantage, then what he essentially found is that such a trait could not arise even in the entire history of the Earth, given known population sizes, mutation rates, and generation times of bacteria. So it sounds like we have a lot of time to produce these features, but if you have a trait that simply requires 7 or more mutations to be present before it gives you any selective advantage towards survival and reproduction, then such a trait outstrips what you might call the probabilistic resources or the available opportunities for such a trait to arise in the entire history of life. Okay, so that's very interesting. That
so
means
time is the first thing. Yes. Okay.
Time and opportunities, sort of the number of organisms that would live, and then the mutation rate. How often do you get mutations? Okay, how often do you get an opportunity to produce something new? All right, so you run all those numbers and you find that actually there are severe mathematical limitations on what can arise in the history of life. And so then you look at these molecular machines. Okay, these molecular machines require not just a few mutations to arise. They require, take a molecular machine like the bacterial flagellum, which is an outboard motor on bacteria that helps it sort of swim through a liquid medium to find food. That molecular machine has over 30 structural parts, okay, and other proteins as well, which are required for its production, for its assembly. So we're talking about perhaps 30 to 50 proteins which are necessary for a bacterial flagellum to function. If you're missing one of them, it doesn't work, okay? You can do what we call genetic knockout experiments and show that it requires at least, all of its 30 protein parts in order for it to function. So you're not talking about just a few mutations, talking about dozens of entire proteins that have to be present in order for this machine to function, to give you any advantage towards survival and reproduction. I can tell you, when you do the math on this, it is not possible for such a feature to arise, even if you give 4.5 billion years of bacteria evolving continuously, which is like the best chance for evolution. That is not enough time for a feature like this to arise.
Wow. This is what I've heard called irreducible complexity. Is that a term that you use?
That's right. That's the term we use, Jeff. It is irreducible complexity is the idea that there are certain features where a core minimum number of parts must be present in order for that system to be able to perform its function. If any part is missing, or if you reduce the complexity, then it doesn't function. So the complexity is what we call irreducible. So that's the basic idea. And there are many features in life which arguably or demonstrably are irreducibly complex. They require a certain core number of parts in order for them to function. They cannot be built in sort of this step by step by step by step gradual Darwinian mechanism that Darwin proposed. It's an all or nothing game. Either all the necessary parts are present and they work and they provide a function, or they're not all present and you're basically dead in the water.
Can I ask you a philosophical question about this? And this is something that you and I've talked about in the past, but given what you've just shared, because I read these articles, I read people, like I read your colleague's Stephen Meyer's book, The Return of the God Hypothesis, and then I read critiques of the book, and they were so dismissive. I mean, so dismissive. They didn't deal with his arguments at all. They actually treated it as, this is not even a discussion. This is not even a real conversation. Why would people be so dismissive in face of the kind of evidence that you've just shared?
I mean, you're asking a sociological question right now, Dr. Jeff, and it obviously has very, very complex answers to that. For some people, if you're talking the scientific community, let's talk about scientists first, okay? So the very famous historian of science named Thomas Kuhn wrote a book called The Structure of Scientific Revolutions. This came out in the 1970s, and it really was sort of this is sort of using a pun here because the book was about the idea of paradigms, but it was a very paradigm-shaping book for how scientific revolutions take place and why scientific ideas change. And one of the things that he talks about is that scientists often have a lot of career investment in the ideas that they are investigating and the research that they're doing. So they tend to be very resistant, actually, to new ideas. It can take a lot of time for scientific communities to change their minds because they have so much funding and research infrastructure invested in, and manpower, human power invested in a particular paradigm. And with that paradigm is shown to be wrong, what tends to happen is that scientific research communities and fields will hold on to those paradigms for a long time before they finally let go of them. They're very resistant, or even the word that Thomas Kuhn uses is intolerant to new ideas that challenge the reigning paradigms. Okay, so this is just normal sociology of how science operates. So we're not at all surprised that we see a lot of opposition to intelligent design, because the reality is this is what we would expect from a new scientific idea, to see this kind of opposition. So we don't get freaked out at Discovery Institute. It's just sort of normal paradigm of resistance to paradigm changing that we see in the scientific community. Now, on a practical level, the topic of evolution and intelligent design carries much larger philosophical implications for a lot of people. Okay, so not every scientist is an atheist. Okay, there's a lot of scientists out there who are not atheists, and even some scientists who would call themselves theists or Christians even, they might disagree with intelligent design. So, I mean, I'm not saying that everybody out there who disagrees with ID is necessarily an atheist or a materialist, but certainly there are a lot who are. And so now you've got a new sociological dimension of worldviews coming into the picture, where people are very resistant to just changing their worldview on a dime, especially if you've invested your whole life in a particular ideology or worldview or perspective. And so that's a big consideration that comes into play for people. I'm not saying that these people, they're just doing it because they're just opposing this conclusion of ID because they're atheists. But, for some people, worldviews play a major role. There's no question about that. Finally, you've got, I guess, you've got sort of the interplay of all this where people just are resistant to changing their minds about things. It's just very hard for people to change their minds. They've got a lot of personal investment. And so when you look at the quality of the objections to intelligent design and you ask yourself, are we seeing logically based substantive objections to ID, or are they sort of, just dismissive arguments where people are almost like they're looking for a reason to get rid of the idea? Well, more often than not, we see the latter rather than the former. We frequently do not see well-reasoned, careful objections to ID. Instead, we see people saying, oh, this is just creationism in cheap tuxedo, or this is religion in disguise, or this is people trying to, sneak God in the science classroom. Well, first of all, I disagree with a lot of that, but none of this has anything to do with answering the science of intelligent design. Or even when they do sometimes give what you might call a substantive objection, it will be so shallow that it's not really a serious objection. I'll give you an example. Sometimes you will hear people trying to explain how the bacterial flagellum evolved. Ken Miller, a biologist at Brown University, loves to cite the fact that some flagellar proteins have what we call homology to other proteins in biology, in bacteria in particular. In fact, in E. coli, where the flagellum has often been studied, we find that some flagellar proteins, about maybe a third of them, have homology to something called the type 3 secretory system, which is another molecular machine that's used to export proteins from inside the cell to outside the cell. Okay, it's used by the flagellum actually during its assembly to help export proteins through the cell, and the flagellum then self-assembles. Okay, so fine. You've got a few proteins that are similar to other proteins in biology, but you have to understand that sequence similarity is not an evolutionary pathway. Okay, just because I find that, say my hammer has a similar shape to, a screwdriver, they're both kind of long and skinny, doesn't mean maybe the handle of my screwdriver is similar to the handle of my hammer, okay? They both have a handle. Does that mean that you could evolve in a step-by-step manner where it's functional the entire way, a hammer into a screwdriver? Well, that's an interesting question, but you haven't demonstrated that just by showing that both of them have a handle, okay, that they have a similar sequence. You have to show a stepwise evolutionary pathway from one structure to the other where it is functional along every step of that pathway and even gaining an advantage along every step of that pathway if you're going to explain how it evolved. And so what you get from evolutionary scientists in response to irreducible complexity is just a couple of proteins that have sequence similarity to other proteins, what we call homology. Well, Michael Behe talks about this. He's a famous ID-friendly biologist. He talks about this in his book, Darwin's Black Box, that finding sequence similarity, that might be evidence of common descent, but that's not evidence of a stepwise Darwinian evolutionary pathway. In no way does it answer the challenge of irreducible complexity. In no way does it provide you with that step-by-step evolutionary pathway that Darwin's theory needs. So when we raise these really potent challenges to Darwinian evolution, and all we get back are, well, there's a couple proteins that are similar to something else. I'm sorry, but that's not an evolutionary pathway, not in any way, shape, or form. So that's a good example of, it looks like somebody's trying to dismiss the argument that we're making rather than actually answering it.
Yeah. That's a great explanation. And Michael Behe's work is really interesting. Of course, he's also spoken at Summit Ministries. I just wonder, and maybe this is why a lot of scientists just don't even comment. And a scientist working in her lab every day wouldn't need to explain the evolution of these molecular machines if what she's doing is studying how they work. Would she? I mean, is it just something is it really necessary for people to say only the material world exists and everything that arose through random chance processes alone in order to conduct their scientific work? Or is this like a philosophy that's sort of added as an icing to the cake?
I think you're onto something there, Dr. Jeff. I think that for a lot of scientists who are just trying to understand the nuts and bolts of how biology works, they don't have to really concern themselves with the origins of these systems. And they don't, because those are big questions that are often very difficult to answer, especially from an evolutionary perspective. There was a a Darwin doubting member of the National Academy of Sciences named Philip Skell. He was a chemist, I believe, at Pennsylvania State University. He wrote an article in a journal called The Scientist a number of years ago. Dr. Skell passed away, I think, about 10 years ago. But before he died, he wrote an article where he talked about a survey he did, where he asked many of his biologist and scientific colleagues if they needed Darwin's theory to do their work. And they actually said, no, it doesn't play hardly any role whatsoever in our efforts to just try to understand how biology functions. So yes, Darwin's theory is interesting, and sometimes Darwin's theory can explain some things. Don't get me wrong. Or the modern version of Darwin's theory, which we call neo-Darwinian evolution, it can explain some things, but we don't need it to explain many aspects of biology. And when we try to use it, it often doesn't work. So I think that is one problem. I think another issue that you run into a lot of times with why people, maybe there are actually some scientists out there, Dr. Jeff, who look, they're open-minded enough to be willing to change their minds on evolution, on origins. They might even be somewhat ideologically sympathetic. Maybe they may not be an atheist, but they believe in some kind of a God, or they're spiritual, as a lot of people say. I mean, many scientists run the gamut of their worldviews. Or maybe they just are open-minded enough that they see the evidence. And when you get one-on-one with scientists sometimes, you can have conversations over a beer or a soda or whatever it is you want to drink. You can have conversations and they'll be open with you. Look, you guys aren't crazy, you ID theorists. I see your points. The problem that you run into is these people, even though they are open-minded, is they realize that if they were to come out as an ID proponent, it would be hugely detrimental to their career. And this sort of goes back to some of the career concerns I mentioned earlier, but I'm talking about there's a particular form of pressure upon scientists in the scientific community that if you come out as an idea proponent in many corners of academia, that is the kiss of death to your career. It's not just that they'll say, oh, you got some weird ideas, you're going to have trouble getting funding for that, but go ahead and try if you want. It's literally like you could be denied tenure. You could not be up for a contract again. You won't be asked to teach graduate students anymore. You won't be asked to teach classes. I'm not just a scientist, I'm also an attorney, Jeff, and I've advised quite a few ID-friendly scientists over the years who've experienced all those negative impacts I just mentioned, literally getting blacklisted from interviews or getting fired from jobs, or students getting kicked out of graduate programs because they questioned the standard Darwinian view or they supported intelligent design. And this is a very real thing, and people are aware of this. I mean, it's just in the air. You don't have to explicitly have a written rule for people to know that it's dangerous to your career to support intelligent design. And so I think that's another major factor for a lot of people.
Yeah. Casey, and I, as an attorney and as a scientist, help me. So I've got a lot of students who are at Summit Ministries right now studying here with us, 180 of them. A lot of them are headed off to a college or university this fall. And they know, especially if they're in a STEM area, they're going to be taking all of these classes and hearing all of this information. They also were motivated, having come to Summit Ministries, to speak the truth in love. What path would you suggest, or what would you do if you went back to your freshman year knowing what you now know that could help them navigate that kind of environment?
Sure. That's a really great question, and we do advise a lot of students. So the number one thing you can do is to get educated about the topic. Don't go in blind. If you're going to Summit Ministries, you can already check that box almost entirely, if not completely. Okay, you're learning a lot of great things at Summit. Another opportunity is, and I don't want to compete with Summit anyway because we only do this for 1 week out of the summer, whereas I don't know, you guys have 10 sessions over the summer or something like that. I can't remember, Dr. Jeff, but we have a summer program at Discovery Institute called the Summer Seminar in Intelligent Design. It usually happens sometime in late June or early July, where students can come and learn about intelligent design from the top scientists and scholars in the field. So that's another great opportunity to get educated in this particular topic, especially if you are going into one of those STEM majors and you're going to be really encountering this kind of material a lot. So check out our summer seminar.
Summer seminar. And what ages of people can attend that?
Well, it's junior class, undergraduates, and higher.
Okay.
So maybe the high school students who are just entering college will have to wait a couple years. So look, Summit is a great place to start. But you can also keep yourself informed by keeping up on certain websites like Discovery Institute's evolutionnews.org website, where we have daily articles covering the constantly changing debate over evolution and intelligent design. We have a podcast called ID the Future. You can get it on idthefuture.com, where we have regular interviews with scientists about the evidence for intelligent design. There's also books that come out, that you can read on your own time. So this is where, unfortunately, if you're going into a STEM field, you're going to learn about evolution. I think that's great. I think students should learn about evolution. In fact, when I give tips to students, I say, look, don't pass up opportunities to learn about evolution. In fact, take those opportunities. My experience was I took almost every opportunity I had during my undergraduate studies to learn about evolution. But if that's all you do, it's not going to be enough. Unfortunately, you have to be somewhat proactive. On your own free time, you're going to have to take time to get educated on your own about some of the alternative views, some of the scientific problems with evolution, and the scientific evidence for intelligent design. This can be true not just if you're going to sort of a mainstream public university or secular college. Even many Christian colleges will push evolution, and essentially that same Dawkins worldview that we were talking about, you can hear that at many Christian colleges today. I know I'm not telling you anything you don't already know, Dr. Jeff. You're well aware of this. But don't assume that just because you're going to a Christian college that you're going to get an education that is sort of objective and willing to think outside the materialistic box. You actually could get quite the opposite at a Christian college. Not all Christian colleges. There are plenty of good ones out there, but just don't assume that. So you're going to have to take time on your own to get educated about this. We have something called the College Students Back to School Guide on Intelligent Design, which is a resource we've developed for college students. If you want easy resources to use, that's one. I also wrote a textbook for sort of advanced high school or early college. I co-wrote the textbook. It's called Discovering Intelligent Design. And it's very easy read. You read this book on your own free time. You can very quickly get up to speed with some of the basic arguments for intelligent design, as well as answers to a lot of common objections that you might be getting from your professor, okay, or professors. So those are some good resources. And if you want resources, I can name a couple others. There's another great book that came out a couple years ago by actually some graduates of our summer seminar. Is called Evolution and Intelligent Design in a Nutshell. These are not very thick books. I know students have a lot of reading to do. If you want something that's on the order of 100 pages, give or take a few, this is a great option. Evolution and Intelligent Design in a Nutshell. It's a great primer on the issue. And then the last one I'll mention is a book co-written by William Dembski and Jonathan Witt titled Intelligent Design Uncensored. It's a great introduction to the topic. I know students are very busy, so these are great opportunities. Again, go to our YouTube channel, Discovery Science News, where we have, I often will, if I don't have a lot of free time to read. So what do? I listen to a YouTube lecture while I'm going for a walk or working out or something like that. Go to Discovery Science News. We have all kinds of lectures, videos, animations. It's a fantastic resource. Makes it easy to learn.
Yeah, this is so great. Well, I know a lot of people who are watching this right now are sitting in front of their computer, so they could easily take the time to check out those resources. Those who are listening right now, maybe you're riding in a car, or you're on the bus, or you are out for a walk listening to this. When you get home, is there one website that you want people to go to sort of unpack all of these resources to help themselves or help their children or loved ones?
Sure. So if there was one website, it would be very easy to remember: intelligentdesign.org. Intelligentdesign.org is sort of designed as our gateway portal to all these other websites, YouTube channels, web resources, all of that. So intelligentdesign.org is a great one-stop shop. A lot of great videos linked there as well. And if I could give one other tip actually to students, some students think that they go into college and they're going to encounter all these sort of, hostile professors, and they might, but it's not necessarily your responsibility, or even is it appropriate for you to feel like you need to go in and challenge what your professor is saying all the time, okay? I found that I was not the kind of student who would rock the boat in class. Okay. Sometimes I might ask a genuine question if I had a question, but it was not my goal to try to, convert the professor to my viewpoint, whatever it might have been. Frankly, when you are just a student before an entire class and your professor is up there, he or she holds all the cards. All right. It's like trying to fight a battle against an enemy who's up on the hill with all the arrows aimed at you. All right. It's not a great environment to try to fight that battle. Much better if you want to reach people, to reach them one-on-one. Students in your class, you can take lunch. So what did you think about that when your professor said this? Or go to your professor's office hours. Professors love it when you come in with honest, genuine questions. And let me tell you, there are a lot of honest, genuine questions to ask about evolution. Go in there wanting to know, I've read about these molecular machines. I would like to know, what is the explanation for how these things evolved? I'm saying that honestly as well. If they do have an evolutionary explanation, I want to know what it is. Maybe there isn't one, maybe there is one, but if there is one, I would love to know. I guarantee you that whatever answer you get, you're going to get an education. You're going to learn either that there's a good answer or there's not a good answer, or maybe your professor will recommend some resources, or maybe they will give you an honest answer saying, look, I don't know the answer to that question. These are hard questions. We're still working on them. Who knows what you're going to get? And so I would say treat your professors with respect. Don't think that the classroom is where you're gonna go and die on that hill. No, it's probably not. Go to school to get educated, and if you get opportunities to reach people in sort of a more private environment, sure, take those if you can. But just have fun. You don't have to win. Some days your professor's going to win. All right, that's just how it is. That's okay. This has been going on since the beginning of time. You will have your opportunities to have conversations with people. And sometimes it's okay for you to just go there, and that experience of just seeing the hostile professor in and of itself might be just the experience that God wanted you to have, to learn what it's like, to get some compassion and appreciation for what goes on, what the pressures that students are up against in the universities, those kinds of things.
Yeah. That is such practical counsel, Casey. Thank you for that. And, you always have to think when you're sitting in a class, the people on the right and the left of me might be my colleagues for the rest of my life. And we might be working in the lab together. If I can show that I'm a good student and I'm spending time with the professor and I know their interests and what they're trying to achieve, maybe I'll get an invitation to work in their lab. You don't have to be at odds in order to be effective.
Absolutely. That's absolutely true. Again, just being who you are, asking those honest questions, asking your professor, I'd like to learn more about this. Do you have any recommendations? Professors love that kind of thing. I think that creating an adversarial relationship usually is not good for you in your short or long-term interests.
Yeah. Well, Casey, this is a fun discussion. I love it. And thank you for giving all of those resources too. So many practical things. So when everybody gets home, you're going to check out intelligentdesign.org, look at all the resources that are available there. And then we're going to look at Discovery Science News.
That's our YouTube channel.
On YouTube. I'm going to check out those videos tonight. I just love this whole idea of the molecular machines, and it's just cool. All right, man. Thank you so much for your time. I really appreciate it.
It's a lot of fun, Dr. Jeff. I enjoyed it and appreciate the opportunity.
Thank you to my guest today, Casey Luskin, for coming on the show. You're going to want to go to intelligentdesign.org to find out more. Now, they've got videos from the Discovery Institute, Discovery Science News on YouTube, lots of books and other resources for you if you are a student, especially if you're in a STEM field, or if you're just kind of curious because you're taking classes and people talk about evolution, or maybe you're a parent or a loved one of somebody who's a student and maybe they're really going through it right now. You want to get some resources to encourage them, sources that have academic credibility, but that also give truth. Then you're going to want to go to intelligentdesign.org to find out more about that. Listen to this from the prophet Isaiah. Lift up your eyes and look to the heavens. Who created all these? He who brings out the starry host one by one and calls forth each of them by name. Because of his great power and mighty strength, not one of them is missing. Knowing that God created the whole universe reminds us that life has meaning, even in those difficult moments. And I hope it reminds you of God's love for you. Thanks for joining the show. We'll see you next week. Listeners, I want you to know that our podcast is on Edify, which is a truly powerful app that brings together thousands of the best Christian podcasts in one place for your listening enjoyment. You can download it at Edify, EDIFI.app. Be sure to share this show if you have enjoyed listening to it. And leave a review, if you would, on the site where you download the show. That helps more people know about the Dr. Jeff Show. And I'll look forward to seeing you next week.